today. Today we are going to solve Leetcode problem 741, cherry pickup. Let me first explain the problem, and then I'm gonna find a way to solve it. After I analyzing the problem, I'm gonna code it up from here, and then analyze the time complexity. So first, let's just analyze the problem. So we are giving a graph. So it is a grid data structure. So the grid is just a 2D matrix. So inside the grid, there are 0, 1, and -1. So 0 means it is empty. It means you can pass through, but you cannot collect anything. 1 means there is one cherry. You can pick up that cherry. And -1 means there is an obstacle. It can be anything, like saw, that is an obstacle. Yeah, but we cannot pass. So this is the obstacle, and this is the cherry. And we want to collect the cherries as much as possible. But we have two ways. One way is we can start from the top left corner, and we can go to the bottom right corner. But we can only move down and move right. Yeah, let me make a drawing. Maybe it's more clear to explain. Yeah, it's like that. We can go two ways, right or down from the top left corner. Or there's another person. So the second person starting from the bottom right. So this guy can go from the left or go to the top. What are we gonna return? We're gonna return the maximum cherries can be collected by those two persons. If you think about this directly, it's gonna be really hard. Yeah, let me just use the white color. So if this is a grid, if there are two persons, one person here, another person here, so this person gonna collect the cherries optimally. It will be like, yeah, let me make it a little bit better, because this guy can only go down, go right, go down, go right. It can be something like that, yeah, and then go to here. Maybe this is the first person. Maybe the second person can go to exactly the same way, but this is not optimized. Because, for example, if there is, here is a cherry. Basically for this person, for the second person, this person needed to go to collect this cherry and then go back, because from before, for example, there's n cherries, but for the second method, if the second person go to this way, so maybe there's, yeah, n-1 cherries. Yeah. So this means if you directly use DP, from the top left for one person and bottom right for another person, you cannot solve the problem because it is not optimized. So what are we gonna do? We're gonna solve the problem differently. We're gonna think differently for this problem. So still there are two persons. So here is person 1 and here is person 2. So those two persons will be standing at the same point, the top left corner or the bottom right corner. It's the same, but for the simplicity to solve the problem, we're gonna use the top left corner. So if person 1 and person 2 are standing at the top left corner, so what they can go? They can only go down and right. So we're gonna turn this problem into a simple problem. This simple problem would be two persons working together. So they are working together. So for the per person, it can go down or go right. So the second person, yeah, it's the same. The second person can go down or go right. Maybe the second person will go right first and then go down. Yeah, maybe the second person will go like that. But as you can see, the two persons will be working at the same time. So in this way, we're gonna solve this problem in a DP, but it's gonna be much easier than you expected. Yeah, there may be some obstacles for some areas, so those two persons cannot go through. But definitely, this problem is solvable by the two persons standing together at the top left corner and can only go down and go right until they go to the bottom right corner. So if one person, yeah, I use the coordinate system, like the position is R1 and C1, comes to the bottom right corner. What about the other person? The other person must also go to the same position. So for R2 and C2 also comes to this position. Why? Because R1 plus C1 equals to R2 plus C2. Yeah, let me make a very simple one. Maybe like this. There are 4 cells. So from here, for person 1, it can go right, go down 2 steps. and for person 2, maybe go down, go right, it's also 2 steps. So their steps should be the same. I mean sum of R1 plus C1 and sum of R2 plus C2. So this means if R1 C1 equals to n minus 1 and n minus 1, and R2 and C2 definitely equals to n minus 1, C minus 1, must meet at the same position. Yeah, so at this position, we only need to check one point. I'm gonna explain it in my code. Yeah, so this is the analysis of the problem. Now we are going to solve it. So how can we solve it? So it's gonna be a DP problem. So for the first position, we know at this point, we need to check. Yeah, because the 2 persons are standing at the same point at this position. So at this position, we're gonna check how many cherries collected. If they are standing at the same position, we just need to check if this cell has a cherry or not. If it has a cherry, we're gonna record it as 1. If no cherry, we're gonna record it as 0. So this means from the first position. But after standing out of the first position, we are not sure if they are standing at the same point or not. We have to collect them together. For example, this is 1 and this is another 1. We're gonna use 1 plus 1. Let me use another color. Yeah, for example, this is 1 cherry, this is another cherry. We're gonna use 1 plus 1. It means collect 2 cherries. From here, we just collect 0 cherries. Yeah, maybe at some point, the person 1 and person 2 both standing at this position. So how many cherries they pick? Only 1 cherries because they are standing at the same position. Yeah, so basically this is the whole idea of the problem. So for me, I'm gonna use DFS plus memorization to solve the problem. And there's another part. So in order to enumerate the different cases, because each person can go to two different positions. So for example, I'm gonna use 1 0. It means this person can go down, and another is 0 1. This means this person can go to the right. Yeah. So for one person can go to 2 directions, and for the second person, this second person can also go the 2 directions. So we're gonna enumerate the different cases. So 2 times 2, there will be 4 different cases. Yeah. So this, according to the 4 different cases, we're gonna use the DT to solve the problem, because maybe at some time, yeah, person 1 may be here, person 2 may be here. It may be the maximum. Maybe at some time, person 1 goes here, person 2 goes here. Maybe that is the maximum. We are not sure. So we have to enumerate all the possible cases, but we're gonna use a DT. Yeah, now let me go back to the code editor to finish the coding. I think the explanation is enough. Yeah, only there's some points in the coding I need to explain. So I'm gonna use DFS. Inside DFS, it's gonna be the positions of person 1 and person 2. So it's gonna be R1, C1. This is person 1, and R2, C2. This is gonna be person 2. So currently, I will give a pass. I will finish the main function first. So the main function is that I'm gonna prepare a variable n. This n will be the length of the grid because row equals to the column. So I'm gonna use a capital N. So then I'm gonna prepare the directions. So there are 2 directions, right and down, because I turned the 2 different problems into one problem. So it's gonna be 0 1. This means the person can go to the right or go down. So 1 0. This means the person can go down. Now I'm gonna just return this DFS. So the DFS would be just 0 0. Yeah, let me. Yeah, I think I just make it changed a little bit. Let me check what happened. Yeah, let me just continue. I don't know. I clicked some place. Yeah, let me make it better. Yeah, let me make it like this. Otherwise, I got too confused. So, yeah. So this is the starting point. This means the person 1 will be standing at the top left corner, top right corner. This is the top left corner, and person 2 will also be standing at the top left corner, and person 2 and person 1 and person 2 will go to the bottom right corner at the same time. Now I'm gonna start the DFS. So for the DFS, let's first check the edge cases. One we can return, and one we need to check the edge cases. We need to check the boundaries. If it goes out of the boundary, we don't need to check it, but we need to return a negative infinity because we need to calculate the maximum value. Yeah. So this means we need to check for R1 because R1 and C1 can only go to bottom right. It means R1 and C1 can only become bigger. It cannot become smaller. So I need to check if R1 more than and equal to n, or C1 more than and equal to n, or R2 more than and equal to n, or C2 more than and equal to n. Yeah, so there are 4 lines. Normally I don't need to write those 4 lines. I can use any check. So any with n more than and equal to n, it means it is true for n inside the array. Yeah, so I'm gonna copy those 4 variables. Yeah, it's because I just want to write it in 1 line because it is more clean. Or grid R1 C1. Yeah, the first person R1 C1 equal to a -1. It is an obstacle. Or grid R2 C2 equals to -1. Yeah, this is all the edge cases. If it is like that, if it is go out of the boundary, what I gonna return? I must return something because my DFS will finally return something. So from here, I need to return a negative infinity because I wanted to choose the maximum value. Yeah, so this is one case. So another case is if R1 equal to C1 equal to n-1. So this means for the first person, it goes to the bottom right. If the first person goes to the bottom right, it means the second person also goes to the bottom right. Yeah, so this is what I explained earlier. According to the mathematical calculation, it must be at the same position to the bottom right. Yeah, because this is the final position, it must be equal. If it is not the final position, they are not equal, maybe. But if it is the final position, they must be equal. Yeah. So we're gonna return a value. It's gonna be the grid R1 C1. So this is for reaching the point, reaching the bottom right. This is for the boundary case. If it goes out of the boundary or it goes to the obstacles, we're gonna return a negative infinity. If it is okay to return the final position, we're gonna return a value. It should be grid R1 C1. It depended on if there is a cherries inside this cell or not. Now we're gonna start the DFS part, but we're gonna need to prepare a current value. The current value is according to our current position. So our current position is grid R1 C1 if R1 equals to C1 and R2 equals to C2. Yeah, this is just means if the 2 persons are standing at one point. For example, they can be standing at this point from the beginning, or they can be standing at some point, maybe here, if the 2 persons standing at one point. Yeah, if they are standing at one point, we just need to use this grid R1 C1 because R equal to C1, R equal to R2. Yeah, R equal to R2 and C1 equals to C2. Yeah, because they are standing at the same position. Else we need to plus all of them. It means grid R1. Yeah, can I make it C1 plus grid R2 C2? Yeah. Yeah, so although I used here grid R1 C1, here I used again, but I think it is still okay. Yeah, this just means if they are standing at the same position, I will use grid R1 C1. If they are standing at the different positions, I'm gonna sum up all of them. So the 2 persons, I will sum up all of them. Yeah. Now I'm gonna prepare the next position. Because for each of the DFS or the DP, basically I'm starting at one position and then I'm gonna move to the next position, but I don't know which position I'm gonna move. I have to check the maximum value. So I'm gonna use a next equal to the negative infinity. Because for the next position I'm not sure. Maybe the next position, maybe there's obstacles. Maybe all the points may be obstacles. Maybe somewhere, maybe here. For example, maybe at this position there's no obstacles, but I come to here. Then I can go right, but there is nothing boundary. I go down, but I cannot not go down. So this means at this position I will get a negative infinity value. Yeah. So this means if I go to here, basically it's a negative infinity. If it is like that, if all of the positions are like that, I mean if I choose the maximum of all the values, it's still negative infinity. I'm gonna return a 0. Yeah, now let me just continue. Now we are going to check the 4 directions. So here I'm gonna use dr1 and dc1 in directions. Yeah, this is just like a brute force. I'm gonna enumerate all the different cases. Yeah, dr2 and dc2 in directions. Now I'm gonna enumerate it. So row 1 and column 1 should be equal to r1 plus dr1 and c1 plus dc1. And similarly, let me just copy it, and I don't want to read it again. Let me just copy it and change it to 2. So this means the person 2. Yeah, so the new position of person 1 is row 1 and column 1. The new position of person 2 is row 2 and column 2. Yeah. Now, what I gonna do? I gonna check the next step. So for the next step, I'm gonna choose the maximum of all the possible results. Currently, the next is negative infinity, but I need to check what gonna be the maximum of all the 4 different positions, because this is basically it will go to 4 different positions. I'm gonna choose the maximum of the next position with DFS. So here I'm gonna use DFS to update it with row 1 column 1 and row 2 column 2. Yeah, let me just copy and change it to row 2 and column 2. So finally I need to return my current value. Yeah, so this is my current value, and plus the next value. Yeah, so this is gonna be the final return. Now let me first run it to check if there's any mistakes. Oh yeah, because here I used this n. I needed to use a capital N, not not lowercase. I needed to use uppercase. Where is it? Yeah, I can't find it. Let me check. Oh, so this N is in line 6. Yeah, it should be here. Now let me run it again. Yeah, I passed the first testing case, but I didn't pass the second. I get a null. Basically, it means I return a negative infinity. Yeah, but if there's no such case, I need to return a 0. So I need to record the DFS as a result. So I need to check this result. I need to return this result if result not equal to negative infinity. Else, I need to return a 0. Now let me run it to check. Yeah, up to now it seems okay, but I forget to use the case. Actually, this is a DP problem. I used the DFS plus memorization, so I'm gonna use a case. Now let me submit it to check if it can pass all the testing cases. As you can see, it passed all the testing cases. Now let's try to optimize the problem a little bit. Because as I explained earlier, there is a formula we need to know about it. It is R1 plus C1 should always equal to R2 plus C2. Otherwise, we cannot solve the problem. Yeah, because R1, the person 1 and person 2 are starting at the same point, and they are moving together. Imagine this is just like playing a game. You have two players, player 1 and player 2 standing at the same position, and they have to move for each of the steps. They have to move for each of the steps. They cannot stand there. Each of the time they have to move. So for the final calculation, R1 plus C1 should equal to R2 plus C2. This means we can decrease the dimensions from 4 dimensions reduced to 3 dimensions. Why? Because 4 dimensions, although we passed, but the time complexity is this is n to the power of 4, and there is a for loop. So those two for loops is basically it is a 4. So let's calculate the time complexity. I think I calculated from here. So basically this time complexity is 50 to the power of 4 and times 4. It equals to 2.5 times 10 to the power of 7. And this is a big number, but it passed for Leetcode. 2.5 times 10 to the power of 7. If it is 8, it cannot pass. Now let me go back. So according to this formula, we know that C2 should equal to R1 plus C1 minus this R2. This means we can reduce the 4 dimension to 3 dimension to solve the problem. Now what we're gonna do? We just need to replace C2 with the formula R1 plus C1 minus C2. Now let me just reduce the 4 dimension to 3 dimension. Let's try to check it. Now we need to check this C2. We're gonna replace this C2 to our formula. Here is also this one, and we're gonna check other C2. Here is C2. Let me just replace all of the C2. This is a C2. Is there any C2? There are 4 variables. We need to delete one. Let me just research if there's any C2. Here is a C2. Basically I need to also replace this one. Now let me just check if there's any C2. It seems there's no C2. It seems everything should be okay. Now let me run it to check. There's something wrong. Takes the 3 variables. Because inside I didn't put it 3 variables. Now let me run it. I deleted more variables. It should be here should be row 2. I deleted more variables. It should be 3 variables. Now as you can see it works. Now let me submit it to check if it can pass all the testing cases. Now as you can see it passed all the testing cases. Although the speed is still the same, but you can see that the memory reduced. If you check all my submissions, the memory actually reduced from 56 to 50 MB. But for the speed it reduced a little bit, but I think that is dependent on the testing cases. But normally the time complexity has already become n to the power of 3. If you check the result, before it is this one. Now it should be, let me just run it to check what it is. Now it should be 50 to the power of 3 times 4. Let's check the result. Now as you can see, it is 5 times 10 to the power of 6, I think. Let me check if it is. It should be 5 times 10 to the power of 6. No, it is 5 times 10 to the power of 5. No, this is I don't know. It is true. So now as you can see, the time complexity before it is 10 to the power of 7. Now it is reduced to the scale of 10 to the power of 5. So that is why we're gonna, if there is a chance, we're gonna reduce the dimensions of the DP. We're gonna always reduce the dimensions. So this is the entire code. I hope you have a basic understanding of this problem. Basically this is a difficult one, I believe, comparing with other DP problems. But if you understand how you're gonna solve it, you're gonna reverse the problem, not solving from both sides, but there will be 2 persons going from the same side and go to the destination together. They may go to the different places, but we're gonna check the maximum of all the possible results. So that's all for today. If you think this is helpful, please like and subscribe. See you next time.